My name is V Edwin and my register number is 25PMC143. As a MCA student, today I will represent a comparative analysis of search algorithms tailored for a specific real-world scenario, optimizing a library management system. We will explore how the choice between linear and binary search impacts the performance and user's experience for a digital library. Let's start by understanding the scale of problem. Imagine our university library database currently holds 10,000 books. Sorry, unlike books, a student rush to the counter and ask for the specific title, for example, Alchemist. If the system performs a manual search by checking records one by one, it would be incredibly slow. To ensure the students get an answer immediately, we need a high-speed algorithm search. The question is which algorithm do choose? First option is linear search. This is often called a sequential walk. Here, how, how it works conceptually. The algorithm start at the first book and check is the target. So it move to next, then no, still no. But if it continues this brute force approach until it finally ends the matches. While symbol this ineffectiveness in the worst case scenario, if the book is the last one in the database, we have to perform n operations for 1 lakh books that need to check 1 lakh checks. Now let's look at the optimized solution, binary search. This is used a divide and conquer strategy. However, remember this crucial requirement. The data must be stored alphabetically. Here is the walkthrough. Step 1. Instead of starting and the beginning, we check the middle of the library immediately. Step 2. If our target is alphabetically after the middle, we completely ignore the left half. We have checked the elimination of 50% of the work in a single step. We repeat this process on a remaining right side until the book is bound. The drastic education reduction in search phase is what makes binary search powerful. Let's prove the difference mathematical using complexity analysis. As you see in the table, the linear search has the worst time complexity of scenario or big O of n. Binary search has a complexity of big of log n. Both utilize own space, but look at the real world impact at the bottom of the slide. If we scale up to 1 million books, the linear search takes 1 million steps. Binary search takes approximately 20 steps. That's the difference between system hanging for seconds versus responding instantly. So is binary search is a perfect solution. Let's evaluate. Focus on the left column. It wins because it handles massive data instantly, which is essential for real-time system where users expect zero latency. Let's focus on the second column. However, the challenges is maintenance because the binary search requires stored data. Every single time we buy a new book, we must insert into the exact correct alphabetic position. This makes adding books slightly slower, but it is a worth trade-off for searching. To conclude, while linear search is easier to implement, it fails at scale. For a university library, handling thousands of records efficiently is not optional. Therefore, binary search algorithm is mandatory to ensure the system is fast, responsive, and professional. This concludes my presentation. Thank you for watching.